Hello everybody, I, Professor Zamre from Department of Civil Engineering, JSPM Nare Technical Campus, Pune. So, today we are having a module of Mechanics of Structure, that is the module over stress-strain curve. In this module, you will learn how strain changes with changing stress for different types of materials. When a body is subjected to deformation, forces are developed inside it. Force which is developed inside the body are the deforming forces, which is equal in magnitude but opposite in directions to the applied force. These resisting forces per unit area is called as stresses, and the deformation caused is known as strain. The relation between the stress and the strain for a given material can be found experimentally. For this, let us take a spring and stretch it by applying force. This causes a change in the length of the string. Now, change the force applied and again note the change in the length of the string. Record the fractional changes in the length of that string, and for this different values can be obtained. Now, plot the graph between the stress equal to the applied force per unit area and the strain produced. The curve so obtained helps us to understand how a given material deforms with increase in load or force. From the graph, we can see that the region between O to A, the curve is linear. In this region, Hooke's law obeys good, that is, stress is directly proportional to the strain. That is, as the stress increases, strain also increases. The body regains its original dimensions when the applied force is removed. In this region, known as elastic region, the solid behaves as an elastic body. In the region A to B, stress and strain are not linearly proportional to each other. In spite of that, the body is subjected to some deforming forces, which changes its dimension when the load is removed. The point B in the curve is known as yield point, also known as elastic limit, and the corresponding stress is known as elastic strength SY of the material. If the load is increased further, then the stress develops exceeds the yield stress and strain increases rapidly. Even for a small change in stress, it is represented by the curve BD. When the load is removed, say at point C in between B and D, the body does not regain its original dimensions. In this case, even when the stress is 0, the strain is not 0. The material is said to have permanent deformation or permanent set. This deformation is said to be elastic deformation, and this region is said to be plastic region. The point D on the graph is the ultimate strain SU of the material. Beyond this point, additional strain is produced even by reduced applied force and fracture occurs at point E. If the ultimate strength and fracture point D and E are closed, then the material is called as brittle material. Examples for the brittle material are glass, slate, antimony and bismuth. If the ultimate strength and fracture point D and E are far from each other, then such material is called as ductile material. The examples for the ductile material are aluminum, copper and steel. The stress strain curve varies from material to material. This figure shows the stress strain curve for the rubber. Although elastic region is very large, the material does not obey Hooke's law over most of the region, and there is no region for plastic. or we can say there is no plastic region. Substances like rubber which can be stretched to cause large strain are called as elastomers. Interestingly, we can say there are so many elastic substances which are present in our human body. For example, the aorta which is present in our heart is a elastomer. Let's recap. The stress strain curve of a material has the following regions. Number 1, elastic region, where the body regains its original dimensions when the applied force is removed. Number 2, plastic region, where an applying a force on the body undergoes a permanent deformation, that is the plastic region. Number 3 is the fracture region, where additional stress is produced even by a reduced applied force and fracture occurs. In the stress strain curve for a brittle substance, the ultimate strength and fracture points lie close to each other. If the ultimate strength and fracture points are far apart from each other, that type of materials are called as ductile materials. Substances which can be stretched to cause large strains are called as elastomers. This is all about for the today's module of stress strain curve. Thanks a lot. Have a good day.